Imagine you are sitting in a completely dark room, with only the faint glow from your computer screen casting a soft light across your face like the last ember in a dying campfire, while outside the window stretches a vast night sky, deep and endless as an ocean without shores, and a gentle breeze rustles through the leaves of the trees, making them whisper like ancient storytellers murmuring forgotten legends from the cradle of the cosmos. You take a deep breath, feeling the cool air fill your lungs like a sip of mountain spring water, and you start to ponder those distant voids, places where distances are measured in light years, vast highways of time where each mile is a year of light racing across the void, where time itself stretches out like taffy pulled slowly in the heat of eternity, and at the very center of it all are entities that make the human imagination hesitate in awe, like a deer frozen before the headlights of an oncoming storm. Black holes. These are not just simple dark pits as shown in science fiction movies with flashy special effects that sparkle like cheap fireworks, but real regions in space where matter is compressed to an unimaginable degree, crushed tighter than a diamond forged in the heart of a dying star, creating a gravitational pull so powerful that even the fastest rays of light, traveling at a speed of 300,000 kilometers every second like arrows shot from the bow of infinity, get trapped and disappear forever, swallowed like secrets into the belly of a silent beast. When you hear about them, you might feel a slight shiver down your spine, as if you are standing on the edge of an invisible abyss that yawns like the mouth of a sleeping dragon, yet at the same time you are drawn in by their mysterious power, much like how a flame attracts a moth, dancing helplessly toward its warm, deadly embrace. In this immense universe, filled with billions of galaxies sparkling like islands of light floating in an ocean of darkness, each one a glittering archipelago adrift on tides of gravity, black holes are described by scientists as the most fascinating astronomical phenomena, keeping them awake through many nights in chilly observatories, like vigilant lighthouse keepers scanning stormy seas, listening to the soft hum of machines that purr like contented cats, with their eyes glued to dancing data on screens that flicker like fireflies in a jar. Although you cannot see them directly through a regular telescope because ordinary light is swallowed up and vanishes as if it never existed, gulped down like a drop of rain into a desert sandstorm, through sophisticated indirect observations using radio waves and X-rays that probe like invisible fingers in the dark, scientists have gathered solid evidence that black holes exist everywhere, especially at the centers of galaxies, where they hide like dark kings ruling over their kingdoms from thrones carved of pure gravity. Picture a galaxy like our own Milky Way, a swirling spiral of light with hundreds of billions of twinkling stars, a cosmic carousel spinning gracefully through the void, and right in its heart is a supermassive black hole, playing a key role similar to the energy source that powers all movement, the conductor of a grand orchestral symphony, keeping the stars from flying apart in all directions like startled birds from a shaken tree but instead orbiting steadily in enormous paths, just like how the heart pumps blood to nourish the body, a rhythmic drumbeat sustaining life. This central black hole influences the entire structure, ensuring stability over vast timescales like an ancient oak rooting a forest, and its presence helps explain why galaxies maintain their beautiful spiral shapes rather than disintegrating into chaos, like petals holding form in a gentle breeze. Black holes are essentially regions of space where the density of matter reaches an extreme level, with gravity so intense that anything crossing the boundary known as the event horizon, an invisible but inescapable line drawn like a chalk mark around a forbidden playground, gets pulled in and lost forever, with no signal ever escaping, silenced like a scream in a vacuum. Try to visualize the scene, a spaceship unfortunately straying too close. At first everything seems normal, gliding like a swan on a calm lake, but as it approaches, time slows down like molasses in winter, space warps and twists like fabric in the hands of a giant tailor, and finally, amid the screeching of metal being stretched apart like taffy in cruel fingers, it vanishes into absolute darkness, consumed like a crumb by a ravenous shadow. If a massive black hole were to suddenly appear near the solar system, though the chance of that is almost zero, but just imagine, its enormous gravity would disrupt all familiar order like a bull in a china shop. Mercury might be yanked off its path first, crashing into Venus with explosions echoing through space like thunder in a canyon. Earth would shake with terrifying earthquakes that rumble like the growl of an awakening volcano, the sky would distort like a funhouse mirror, and, eventually, the whole planetary system we live in, with its bustling cities that pulse like hives of busy bees, green forests that sway like dancers in the wind, and vast oceans that roll like the breath of a sleeping giant, could collapse in uncontrollable chaos, leaving only faint echoes of destruction, whispers carried on solar winds. Such a scenario highlights the raw power of these objects, reminding us how delicate the balance of our cosmic neighborhood truly is, a house of cards perched on the edge of a table, even though in reality, the nearest black holes are safely distant, lurking like wolves beyond the campfire's glow. Now, narrow your view to our closer home, the Milky Way, where our sun is just an ordinary star in the suburbs, a humble cottage on the outskirts of a grand city, orbiting the center at a dizzying speed like a runner on an endless track. Have you ever wondered, in that vast galaxy with stars being born and dying over billions of years like flowers blooming and wilting in a timeless garden, how many black holes quietly exist, silent predators prowling the underbrush? Scientists, after years of analyzing data from satellites and telescopes, from long nights in high mountain observatories where the air is thin and bitterly cold like the breath of winter itself, estimate there could be hundreds of millions of black holes, mostly of intermediate mass, formed after the dramatic but spectacular deaths of massive stars, those huge balls of fire that once shone brilliantly like blazing suns in a midnight festival, then exploded in dazzling supernovae, with light spreading across thousands of light years like ripples from a stone thrown into a cosmic pond, leaving behind a silent black hole that devours everything nearby, a bottomless well echoing with the ghosts of stars. But the most prominent, drawing all attention from the scientific community like moths to a porch light, are the supermassive black holes at the galaxy's center, around which all the stars in the Milky Way, including our warm sun that lights our days and warms our summers like a faithful hearth, quietly orbit in a spiral lasting hundreds of thousands of years, like a rhythmic and endless cosmic dance, partners locked in an eternal waltz. These central giants not only anchor the galaxy but also influence star formation in surrounding regions, sometimes triggering bursts of new stars through their gravitational interactions, like a conductor waving a baton to birth a chorus of light. In casual conversations at astronomy conferences, amid the drip of coffee that falls like slow rain and lively chatter that buzzes like a beehive, scientists often compare these central black holes to cosmic engines, because of their core role in shaping and maintaining the motion of the entire galactic structure, the heartbeat driving the body's circulation, keeping the spiral arms from falling apart like threads from a fraying rope, allowing stars to move in harmony like notes in a symphony. Of course, this is just a metaphor to make it easier to understand, to convey that wonder to the public like a storyteller spinning yarn by the fire, rather than formal terms in dry astronomy textbooks that read like ancient scrolls, but it helps us feel that silent power, like the low rumble of a car engine under the metal hood, unseen but always there, a steady thrum beneath the surface. This analogy extends to how black holes can fuel active galactic nuclei, where infalling matter heats up and emits tremendous energy, powering quasars that outshine entire galaxies like lighthouses piercing the fog of night. Pause for a moment and travel back in time to the 10th of April in the year 2019, a day when the atmosphere in research centers worldwide was tense like a taut string on a violin about to snap. At the arid Atacama Observatory in Chile, desert winds whistled through giant antennas like ghosts through a graveyard. In freezing Antarctica, snow gently fell on equipment like a blanket of silence, and everywhere, hundreds of scientists sat close together in front of screens, breathing excitedly like runners at the starting line, clutching cold coffee cups that steamed like morning mist. That was when humanity first observed a real image of a black hole, not from a single telescope alone on a mountain like a solitary sentinel, but from the massive project called the Event Horizon Telescope, a network of radio telescopes scattered across Earth. From lush Pacific islands that bloom like emeralds in blue seas to sunny European lands golden with wheat, all synchronized to the thousandth of a second, functioning as one telescope the size of our entire planet, a global eye staring into the abyss, collecting data in silence broken only by the soft whir of computers that hum like distant bees and excited whispers that flutter like birds. This global collaboration involved thousands of hours of planning, calibrating instruments across continents like tuning a vast orchestra, and overcoming challenges like weather disruptions that rage like tantrums and data synchronization that demands precision sharper than a surgeon's blade. Their target was the supermassive black hole at the center of galaxy Messier 87, in the Virgo constellation, a distant galaxy whose light takes about 55 million years to cross the cold void and reach human eyes, a message in a bottle from a ship long sunk. That black hole has an estimated mass of about 6.5 billion times the Sun's mass, a huge number that makes you pause and try to grasp like holding sand in your fist. If the Sun were a table tennis ball bouncing lightly, this black hole would be a towering mountain piercing the clouds. This was the first celestial object humanity observed indirectly using millimeter wavelength radio interferometry, with enormous data transported by plane across oceans because it was too large for networks, a cargo heavier than elephants, processed over many months amid the click of keyboards that tap like rain on a tin roof. When the final image appeared, a hazy glowing orange ring against black, like a halo around a shadowed face, the scientific world erupted in joy, with applause echoing like thunder in a valley, tight hugs that squeeze like bear embraces, and even tears of emotion rolling like dew on leaves, ushering in a new era for studying these mysterious gates of the universe, where space and time bend in ways never seen, like roads twisting in a dream. The image revealed the shadow of the event horizon silhouetted against the accretion disk, a portrait of gravity's grip, confirming predictions from general relativity and inspiring new generations of astronomers like seeds sprouting in fertile soil. Building on that brilliant success, on the 12th of May in the year 2022, the research atmosphere bubbled again like champagne in a glass. In online meeting rooms and observatories, everyone held their breath in anticipation, hearts pounding like drums in a ritual. The Event Horizon Telescope made history once more by releasing the first image of the supermassive black hole named Sagittarius A star, right at the center of the Milky Way, where our Earth, with its continents that sprawl like patchwork quilts, oceans that heave like the chest of a dreamer, mountains that stand like ancient guardians, and bustling cities that twinkle like fireflies at dusk, is just a tiny part, a speck on a vast canvas. In the widely shared photo, the black hole appears as a faint glowing circle, not because it emits light itself, since it is absolute darkness, a void deeper than midnight, but because light from superheated gas at millions of degrees and cosmic dust around it is bent by extreme gravity, creating a special visual effect like a fiery donut in dark space, a ring of flame encircling oblivion, with the screech of torn plasma in the data wailing like banshees in the wind. This is the most vivid proof of Einstein's general theory of relativity, from over a century ago when he sat in a quiet Berlin office, pipe in hand puffing clouds like thoughtful genies and blackboard full of equations scrawled like mystic runes, hypothesizing black holes without dreaming of real images emerging like photos from darkroom chemicals. Capturing Sagittarius A star was particularly challenging due to its rapid variability, a beast that shifts like sand dunes, requiring advanced algorithms to average out fluctuations over observation periods, taming the wild data like a rider breaking a stallion. Sagittarius A star has an estimated mass of about 4 million times the Sun's mass, equivalent to around 1,320 billion times Earth's mass. Try multiplying the mass of all oceans that surge like liquid giants, mountains that rise like frozen waves, and people on our planet bustling like ants by billions to imagine a weight that crushes scales. The diameter of its event horizon is about 25 million kilometers, large enough to swallow Mercury's orbit several times like a whale gulping krill, and it is about 27,000 light-years from Earth, meaning the light we see today is from the Stone Age, when our ancestors hunted in dense forests with spears like thorns, their fires flickering like stars on the ground. Scientists, with voices full of wonder and respect that ring like bells in a cathedral, say this is one of the most mysterious and captivating objects in the universe, though not visible in ordinary light, only through radio waves and X-rays that pierce like arrows through fog. But this supermassive black hole acts as the gravity center for the whole Milky Way, making all stars, including the Sun with its brilliant solar storms that flare like dragon's breath, orbit it in a slow dance lasting millions of years, a ballet on a stage of stars. That's why, in articles and interviews, researchers often call Sagittarius A star the heart of our galaxy, for its control over the structure and motion of hundreds of billions of stars, like how the heart regulates the body's rhythm with steady beats, though we don't see it beating, hidden in the chest of the cosmos. Ongoing monitoring shows it occasionally flares up, devouring nearby gas clouds like a sleeper stirring to snack, providing insights into accretion processes that flow like rivers into a sinkhole. If you are curious about classifying black holes, imagine scientists around a meeting table with charts and data spread like a feast, dividing them into 3 clear levels based on mass, sorting cosmic fruit by size. The first type is stellar mass black holes, children of massive stars, with mass under 100 times the Sun's, formed from supernova explosions with blinding light illuminating the galaxy for weeks like a fireworks finale that lingers. The second type is intermediate mass black holes, rarer, elusive like unicorns, with mass from 100 to 1,000 times the Sun, perhaps from mergers of smaller black holes in dense star clusters that crowd like cities in the night. And those over 1,000 times the Sun's mass are called supermassive black holes, the true bosses dominating galaxies like lions ruling the savannah. Generally, for a stellar mass black hole to form, the original star must have at least 3.2 times the Sun's mass. If less, it shrinks into a neutron star or white dwarf, with high density but still faintly glowing like embers in ash. These classifications help in understanding evolutionary paths, from isolated formations to complex interactions in binary systems or galactic cores, trails in a vast forest. In September of the year 2022, in the excited research atmosphere at the Smithsonian Astrophysical Observatory at Harvard University in the United States, where hallways are filled with astronomy posters that flutter like flags and the smell of old books wafts like incense, researchers discovered a dormant black hole just 1,600 light-years from Earth, the closest ever observed by humanity, a neighbor peeking over the fence. Its mass is 10 times the Sun's, and they named it Gaia BH1, sounding like a friendly nickname whispered in confidence. This is a very special celestial system because a normal star orbits this black hole, forming a binary pair of black hole and star, like a dangerous tango couple in the dark, steps precise on a knife's edge. Picture that star, shining brightly but trembling like a leaf in the wind, spinning rapidly around the deadly shadow that looms like a predator in wait, gravity pulling hard but distance just enough to avoid being swallowed, a tease on the brink. Perhaps the star is gradually losing material through stellar winds that blow like sighs, creating a hot accretion disk that glows like a forge. Why doesn't it get pulled in? Scientists are seeking answers through computer simulations that whirl like dervishes, with long nights of heated debates that crackle like campfires, pens scratching on whiteboards like claws on bark, and hope to find clues about how such pairs remain stable, a delicate balance on a tightrope. This discovery, made using data from the Gaia spacecraft that maps stars like a celestial cartographer, has opened new avenues for studying black hole demographics in our galactic neighborhood, counting shadows in the attic. However, turning to supermassive black holes like those in Messier 87 or the Milky Way's center, the question of how they form always keeps scientists restless, pacing like caged tigers. The process is very complex, requiring billions of years in the chaotic early universe, a forge where galaxies are hammered into shape. Initial theories suggested they start from a stellar mass black hole in the young universe full of gas and dust that swirl like storm clouds, continuously absorbing surrounding matter over immense time, gas pulled in at terrifying speeds like rivers rushing to a waterfall, heating to billions of degrees that blaze like infernal furnaces, emitting blinding X-rays that streak like lightning, gradually growing into supermassive, a seed becoming a titan. But in recent years, astronomical studies from the Hubble to James Webb telescopes that peer like wise owls have revealed a deeper link between supermassive black holes and galaxy formation, twins born together in the cosmic womb. Most galaxies in the universe formed over 10 billion years ago, in the Big Bang's aftermath with echoing explosions that boom like primal drums, and at the center of most is a huge black hole, the keel of the ship. These may form from direct collapse of massive gas clouds with hundreds of thousands or even millions of times the Sun's mass, under self-generated gravity that pulls like inexorable fate, clouds contracting amid gas collision screeches that wail like sirens, heating, and sudden collapse without a star phase, a plunge into darkness. This extreme gravity field shapes the galaxy's structure and star orbits, like an invisible architect drawing the cosmic blueprint with a steady hand, lines of fate. Feedback mechanisms from these black holes can regulate star formation, either quenching it by expelling gas like a breath blowing out candles or triggering it through compression like squeezing fruit to juice. So in our Milky Way, with meteor showers streaking across nights like shooting stars granting wishes and auroras dancing at the poles like veils in the wind, how many black holes are there, hidden like treasures in a pirate's map? Scientists estimate, based on star birth and death rates that cycle like seasons, that for every 1,000 stars, only one becomes a black hole after death, usually those over 8 times the Sun's mass, living short but brilliant lives like mayflies in summer sun. Our Milky Way has at least 100 billion stars, from red giants that swell like overripe fruit to cool white dwarfs that fade like old memories. Thus, the number of black holes in the Milky Way is at least about 100 million, a scary figure when you stargaze and think millions of invisible shadows lurk around like ghosts in a haunted house, though thousands of light years away and no direct threat, distant thunder. Population studies suggest many are in binary systems, occasionally revealed through X-ray bursts that flash like signals or gravitational microlensing events that bend light like lenses. On the 10th of April in the year 2023, American astronomers in an observatory with wind howling through the dome like a chorus of wolves discovered a runaway black hole, seemingly escaping its host galaxy after a massive galactic collision that shook like tectonic plates. It races wildly through the universe at thousands of kilometers per second, a comet with a dark heart, trailing a tail of torn gas and stars that stream like a bridal veil in tatters, like a lone wandering black hole in cold emptiness, an exile in the void. The research team, after hours of data analysis that grind like millstones, pointed out that if confirmed by further observations, this would be the first observed evidence of a supermassive black hole ejected from its galaxy, perhaps by gravitational wave recoil from 2 black holes merging, a kick like a mule, and roaming intergalactic space, potentially causing havoc if encountering another galaxy, a storm on the horizon. Such ejections are predicted in simulations of galaxy mergers, leaving behind stripped cores and altered structures like battlefields after war. So how big are the largest black holes in the universe, titans among giants? So far, the biggest discovered by humanity is Phoenix A, at the center of the Phoenix galaxy cluster about 5.8 billion light-years from Earth, light starting when Earth was primordial, a fossil from the dawn. The Event Horizon Telescope shows its diameter about 600 billion kilometers, mass 100 billion times the Sun's, a colossus that dwarfs worlds. To visualize, the Sun to Pluto distance is about 6 billion kilometers, a modest leap, so Phoenix A's diameter is 100 times that, a gulf wider than dreams. Even the largest known star by volume is Stephenson 218, a red supergiant with diameter 1.5 billion kilometers, large enough to engulf Saturn's orbit like a monster swallowing a moon. Thus Phoenix A is still 393 times larger, a scale making our solar system seem like a grain of sand on an endless beach, insignificant yet part of the shore. Ultra-massive black holes like this may anchor the largest structures in the universe, influencing cluster dynamics over cosmic scales like roots binding soil. In reality, black holes are remnants of stars that ended their lives in supernovae, terrifying explosions with energy of billions of nuclear bombs that detonate like the wrath of gods, blinding light illuminating the galaxy for months like a beacon in the fog. At a black hole's core is the singularity, where after the star dies, mass compresses to a single point of zero size and infinite density, a pinprick holding infinity, challenging all familiar physics laws like a riddle without answer. This singularity creates the black hole's powerful gravity field, even light cannot escape, turning the surroundings into absolute darkness, a cloak thicker than night. Through studying black holes, with computer simulations running day and night like tireless weavers and space telescope observations that gaze like patient eyes, scientists are step by step decoding the universe's deepest mysteries, From cozy labs that glow like hearths to lively international conferences that buzz like markets. Black holes are not just keys to better understanding gravity's nature and physics laws in extreme conditions, where time stops like a frozen river and space bends like a bow, but also provide crucial clues about universe evolution, space-time structure like a stretched fabric woven on a loom of fate, and the nature of dark matter and dark energy, two components making up most mass and energy in the universe but still great enigmas puzzling generations of scientists like locked chests. These studies intersect with particle physics, cosmology, and even information theory, debating paradoxes like information loss that tease like koans. Updated to the year 2025, with advancing technology that blooms like spring, the Event Horizon Telescope has been upgraded with new observatories in Africa and South America, eyes added to the global gaze, providing sharper images of Sagittarius A star, showing periodic gas eruptions every few hours like a giant's sighs that rumble through the void. Supercomputer simulations from NASA, running on thousands of processing cores with cooling fans humming like choirs, reveal black holes might connect to parallel universes through quantum gravity theory, with theoretical wormholes sparkling in imagination like portals in fairy tales. Most recently, the James Webb Space Telescope, floating in cold space like a solitary monk, discovered the oldest black holes from the early universe, just a few 100 million years after the Big Bang, weighing millions of times the Sun despite young host galaxies that toddle like infants, completely challenging old formation models and forcing theorists to rewrite textbooks amid pen scratches that etch like chisels on stone. Additionally, the LIGO-Virgo-Kagra gravitational wave network has recorded dozens of black hole collision events, with a notable one in 2024 when two stellar mass black holes merged into a new intermediate one, gravitational waves rippling through space like pond surface waves stirred by a pebble, detected on Earth via sensitive instruments that listen like ears to the ground. These advances not only excite the scientific community with packed international conferences and echoing applause that resounds like victory, but also open hope for better understanding black holes' role in universe expansion. Perhaps they are the seeds for all galaxies, kernels sprouting into forests. And the long story about these dark giants ends here today. Thank you for patiently listening through every detail like a traveler by the fire, hoping you feel the universe is no longer distant but closer, a familiar friend full of wonders and mysteries waiting to be explored like paths in an ancient wood. Perhaps on some starry night, you will look up and smile at them, winking back from the velvet sky.